For today's lesson, we are going to use partial fractions to integrate our rational expressions. Go ahead, give questions A and B a try. Afterwards, we will discuss them. First, you should have factored your denominator, then written a constant A over your first factor and a constant B over your second factor. We then find a common denominator. I usually do cross multiplication. So I have A times x plus 1 plus B times your x minus 4. Since your denominators will be equal, we do not need to write them. We want to solve for both A and B. I'm going to start by letting x equal -1. And when x is equal to -1, I will get -15 equals 0 when I do my substitution, plus b times -5. Divide, b is going to be equal to 3. Next, we're going to find the value of b. For this one, I'm going to let x equal 4, do my substitutions, and I have 10 equals a times 4 plus 1 is 5, and the second part of the expression is 0. So a must be equal to 2. So what we know is that this rational expression can be rewritten as 2 over x minus 4 plus 3 over our x plus 1. We're going to use this idea for part B. We cannot use substitution to integrate question B, but we could use algebra. And that algebra, again, is rewriting rationals using your partial fractions. We've already rewritten this partial fractions. We're going to write it as the integral to x minus 4 dx plus the integral from 3 over x plus 1 dx. Now, the antiderivatives are lovely little natural logs. Don't forget to put in your absolute values. And then we will have plus 3 times the natural log, absolute value of x plus 1, and of course, plus c. Now, you should be aware that you can collapse your natural logs. So your answer in a multiple choice test might look like the log of the quantity x minus 4 squared times your x plus 1 cubed, and all of that will be part of the argument of your log, and then we will have a plus c. So be aware that on a multiple choice test, you could have your answers in various forms. For example 1, let's take a look. We want to start by factoring our problem. We're going to rewrite this problem as the antiderivative of 1 over x plus 2 times x minus 1, and here's my dx. Now we want to rewrite this question into two different parts. So 1 over your x plus 2 times your x minus 1 is equal to a over x plus 2 plus b over x minus 1. We will cross multiply so that we have a times x minus 1 plus b times x plus 2, and that has to be set equal to 1. Again, you get to choose some x values in order to solve the systems of equations. If we let x equal 1, we will have the equation 1 equals b times 3. So b must be equal to 1/3. Well, next let's let x equal -2. So 1 equals a times -3, and the next part of the expression again is 0. So a equals -1/3, which leads us to rewriting our antiderivative. We'll have the square root. Now the a value has to go with your 1 over your x plus 2, and I'm going to multiply this by -1/3. And then we will have plus, the b value is 1/3, and then we're going to rewrite that as 1 over x minus 1. Oh, don't forget those dx's, get those in there. Then you integrate, we have -1/3, natural log, absolute value of x plus 2, plus 1/3 natural log absolute value of x minus 1 plus c. And if you want to rewrite the problem so that you have one natural log, you would keep your x minus 1 in the numerator and x plus 2 in the denominator, and this would be raised to the 1/3 power with, of course, plus c. Example 2 is going to be a little bit more interesting. Something you should notice, our factors were linear, and when you have a linear factor, you're going to place constants above the linear factors. We don't always have linear factors though, so let's take a look at example 2. Rewrite your problem. We have the integral 2x plus 4 divided by our factoring x squared out, like x minus 2, and then we have a dx. Next, we have 2x plus 4 divided by our x squared times x minus 2 is going to be equal to, all right, let's do a over x minus 2. Now, take a look at our next piece of the puzzle here. We have x squared. X is going to be squared. That's quadratic. We need to have a linear expression written in the numerator if we're going to use partial fractions to rewrite the problem. And we can simplify that a little bit more as x minus 2 plus our b over x plus our c over x squared. If we do not find the, if we do not write that line, we're not going to come up with the correct values for A, B, and C. So now, we're going to find common denominators. We have a x squared plus, take your b, that's going to be multiplied by x, and it's also multiplied by x minus 2. The c value will be multiplied by x minus 2. All right, let's let x equal 0. When x equals 0, 4 equals negative 2c. So c must be equal to negative 2 in this problem. All right, let's next let x equal 2. That'll be useful. If we do that, 8 equals 4a. The b value will be gone, plus the c was negative 2. Filling in a 2 also gives us a 0, so we know then that a is 2. Almost there. Just need to pick another number. I'm going to let x equal 1 this time. And if x is 1, I get 6 equals a plus my, but a is 2. Let's rewrite that as a 2. So we'll have 2 plus b. The x value is 1. I'm going to be left with negative 1 plus my c value, which is negative 2 times negative 1. Simplified, we get 6 equals 4 minus b. So that means that b must be equal to negative 2. All right, now we put it all together with our integral. Rewrite our problem. This is going to be equal to the integral of my a value, which is 2 over x minus 2, plus my b value, which is negative 2 over x, plus my c value, which is negative 2 over my c squared. Excuse me, that's x squared. Don't forget your dx. And then you should be able to integrate this problem with no challenge at all. So go ahead and get to work on it. Let's begin example 3 by factoring. We have our 3x cubed minus our x squared plus 3x minus 1. Factor by grouping gives me x squared times x, 3x minus 1 plus another 3x minus 1. So we could rewrite this integral as x squared plus x minus 2 divided by 3x minus 1 multiplied by x squared plus 1. And that cannot be factored anymore. All right, we're ready to get started with more algebra. So we take the x squared plus x minus 2 and we divide it by our 3x minus 1 times x squared plus 1. We know that that is going to be equal to a, which is constant, divided by 3x minus 1, which is linear, plus, now the denominator for this one is quadratic, so we're going to write bx plus c in order to rewrite this problem as partial fractions. Next, we find our common denominator, x squared plus x minus 2 has to be equal to a times your x squared plus 1 plus your 3x minus 1 multiplied by your bx plus c. Okay, next we're going to figure out the a, the b, the c. First, let x equal 1/3. When x is 1/3, I have 1/9 plus 1/3 minus 2 is going to be equal to a times 1/9, so that's going to be 10/9. Now I'm going to multiply by 9/10 on both sides, simplify, and I should have my a value. And what we come up with is that a is equal to -7/5. Not very pretty, but we can handle it. All right, so we now have a is -7/5. Substitute that in for your a value. Next, if we were to let x equal 1, we don't have a lot of good choices here. I'm going to let x equal 1. So when I have x equals 1, 0 equals 2a. Oops, but I know my a value. Let's get rid of that a. Put in -7/5. There we go. 2a. Plus our 2. And then we have b plus c. Okay, let's clean this up a little bit. 14/5, so we have -14/5 equals your 2a plus b. Let's divide this by 2. So there's my b plus c. Okay, simplify. We have -7/5 is equal to b plus c. That doesn't look so hot, so let's try this again. This time I'm going to let x equal -1. Let's see what happens with that. We know that -2 is equal to your a value, which is -7/5, times 2 plus, we'll have -4, times our b, it's going to be -b plus c. There we go. Clean this one up. Let's multiply everything by 5, which gives us -10 equals 14, -14, and then we'll have -20 times -b plus c. All right, so 4 divided by our -20, which are equals our -b plus c. Now we have a lovely systems of equations. -7/5 equals b plus c. We also have -1/5 equals -b plus c. When we solve this system of equations, we come up with b is going to be equal to 4/5 and c is equal to 3/5. All right, with that, next you rewrite your problem, filling in your b and your c values. So once you filled in your b and your c values, notice I put the 1/5 out front, and here's my a. The first part of our expression, or integral, comes out very nicely. Second part, you're going to have to do more work. So we're going to bust this up using 4x over x squared plus 1. That is now a u substitution problem. And then we have 1/5 times 3. Here's my integral of 1 over x squared plus 1 dx. And hopefully that one also looks very familiar. All right, go ahead and finish this problem. Have a great day.